Hi, I'm Adnan Akbar, MPhil in Physics and BS in Mathematics. And today I am here with my YouTube channel. And in our lecture number one, we have to discuss the Coulomb's law. We will cover our first topic in some contents, which are history, statement, derivation of relation, effect of medium, value of K, permittivity of free space, relative permittivity, Newton's third law, Coulomb's law and law of gravitation, superposition principle, and limitation of the Coulomb's law. Okay, let's start from the history behind the discovery of the Coulomb's law. It was 1777 in the Paris Academy. There was a competition to develop a very low friction campus to detect the magnetic disturbance, and Coulomb's won that competition. And after that, he performed a torsion balance experiment and published his Coulomb's law in 1785. Let us discuss a little about the torsion balance, how it works. Actually, it consisted on a horizontal non-metallic rod, and two spherical metallic bodies are connected with its ends, and one of them is charged, and they are suspended by a thread in the glass vacuum jar as shown in the figure. Then he insert another sphere that was also charged, and let's check their effect in that animated diagram. And you can see in animated diagram, when two charged sphere come close to each other, then they repel to each other, and their repulsion and angle of deflection was mirrored on the scale surrounding the vacuum jar as shown in the figure. After this experiment, Coulomb concluded two things. One was that whenever two charges come too close to each other, then there is a force between them that can be repulsive or attractive, depends on the type of charge. Secondly, he concluded that when we increase the distance between 2 point charges, then the force between the charges is reduced. And when the distance is reduced between the charges, then the force between the charges is increased. And on the basis of these 2 points, he stated his Coulomb's law. Let us check its statement. This law states that the magnitude or the absolute value of the attractive or repulsive electrostatic forces between 2 point charges is directly proportional to the product of magnitude of their charges and inversely proportional to the square of distance between them. And we can write it mathematically: F is equal to K Q1 Q2 over R square. Q1 and Q2 are the charges, and R is the distance between them. K is proportionality constant, and F is the Coulomb force between these 2 point charges. In the figure, we can see 2 point charges are separated by a distance R, and actually this Coulomb's law describes the interaction of the charges on each other. And a specific point, that is point charge, is also shown in this statement. Let us check what is this point charge. Point charge does not have any specific definition. Two rounded objects on which charges are distributed are said to be point charge when they are at much larger distance apart, seems to each other like a point, then they are said to be point charge. And now let us drive the relation for the Coulomb's law. Consider we have 2 point charges Q1 and Q2 are separated by a distance R, and there is a force between them. And according to the first part of the statement, that force between 2 point charges is directly proportional to the product of magnitude of the charges. And according to the second part of the statement, force between 2 point charges is inversely proportional to the square of distance between them. From the second part, if we increase the distance between the 2 point charges to a double value, then the force between 2 point charges will be reduced 4 times, because force is inversely proportional to the square of distance. Let's combine these two relations, and we have a relation F is proportional to the Q1 Q2 over R square. After removing the proportionality constant, we have the relation F is equal to K Q1 Q2 over R square, and K is equal to 1 by 4 pi epsilon naught, which is a proportionality constant that we have to discuss in next slide in detail. Value of K and its dependence in our this slide we have to discuss. K is actually is equal to 1 by 4 pi epsilon naught. In this equation, 4 pi is a constant. Epsilon naught is actually permittivity of free space, which is related to the medium. We can say K depends on the medium, and here medium epsilon naught permittivity of free space is showing that K is inversely proportional to it. So we can say when we will introduce a solid material medium between 2 point charges, then its permittivity will be high, and as a result, the force between 2 point charges will be reduced. As a result, value of K will be low. As a result, the force between 2 point charges will be reduced. On the other hand, if we will introduce a simple medium like the air or the vacuum between 2 point charges, then the permittivity of that material medium, like the free space or vacuum, it will be low. Actually, permittivity of free space, the permittivity of vacuum are not a material medium, and in that case so numerical value will be very low. As a result, its effect will be low. Then K, that is inversely proportional to the permittivity, will be high, and the force between 2 point charges will be more effective and high. On the other hand, it also depends on the SI unit in which quantities are measured. For example, in Coulomb's law relation, force F is measured in the Newton, and charges are measured in the Coulomb, and distance between them is measured in the meter. Let us discuss in our next slide effect of the medium that is actually related to the permittivity of free space, and relative permittivity. Permittivity is actually property of the medium. It will decide how much force between 2 point charge will be weak or strong. The permittive force between 2 point charges is actually inversely proportional to the permittivity. In case of free space, value of the permittivity is 8.85 cross 10 to the power minus 12 per Newton per Newton, and meter square per Coulomb square. And in this case, relative permittivity, we can define relative permittivity. Relative permittivity is actually the permittivity in the presence of some material medium, not a vacuum, just a material medium. Then we will consider that a relative permittivity. Relative permittivity is actually the ratio of the permittivity of the material medium to the permittivity in the absence of any material medium. And we can also define it in terms of the forces. It is actually the ratio of the force between 2 point charges in the absence of material medium to the force between 2 point charges in the presence of material medium. And here we have epsilon r is always greater than or equal to 1. And after introducing it in the Coulomb's law, F is equal to 1 by 4 pi epsilon naught epsilon r q1 q2 over r square. And here again it is clear that force between 2 point charges is inversely proportional to the relative permittivity. And again we have a table where some material medium and their corresponding permittivities are given in the table, you can see. And let us move towards our next slide, which is about the Newton third law. Newton third law, is actually about the action and reaction in the nature of when we apply a force on a body, then similar but in opposite direction is a force is applied on us by that body. Similarly, in case of electrostatic, when a charge apply electrostatic force on another charge, then similar but opposite force is applied on the first charge. We have a figure. You can see Q1 and Q2 are charges separated by the r distance, and Q1 is applying a force on Q2, that is F21. Similarly, as a reaction on force, Q2 is applying on the Q1, which is F12. F12 is equal to K Q1 Q2 over R square directed in R21. Similarly, F21 is equal to K Q1 Q2 over R square directed R in R12. As they are opposite in direction, so their unit vector will be opposite to each other. And similarly, forces are opposite in direction. F21 is equal to minus F12, and negative sign is representing that forces are opposite in direction. And but their magnitude will be same. So in case of magnitude, F21 is equal to F12. Okay, let's compare the Coulomb's law and universal law of gravitation. First, we have their formulas. F is equal to KQ1 Q2 over R square, and F is equal to G M1 M2 over R square. In case of Coulomb's law, electrostatic force is actually between the 2 point charges. In case of universal law of gravitation, gravitational force is actually between the two masses. And in the case of proportionality constant, K is equal to 9.1 cross 10 to the power 9 Newton meter square per Coulomb square, which is much larger value. And while the proportionality constant in case of gravitational law, G is equal to 6.67 cross 10 to the power minus 11 Newton meter square per kilogram square, which is much smaller value. We can say that Coulomb's constant is greater than the gravitational constant G. Coulomb force is actually stronger force, and gravitational force is weaker force. Coulomb force can be shielded. It is medium dependent, while the gravitational force is medium independent, so we cannot shield it. Coulomb's force is actually can be repulsive or attractive, while the gravitational force is always attractive. And there are some similarities we have to discuss. Both obey inverse square law. We have observed in both formulas, F is inversely proportional to the R square, which is showing that in both cases, both laws are obeying inverse square law. And in both cases, force is acting along the line joining their center. Like in the Coulomb's case, force is along line joining the center of point charges, while in case of the gravitational law, force acts along the line joining the center of masses. And let us discuss the principle of superposition. Superposition principle actually shows the collective effect of individuals. And here we consider that n number of charges are applying a force on a charge Q1, and their collective effect will be actually the sum of the forces of individual, to which we can write mathematically. Net force is equal to F12 plus F13 plus F14 plus F21 plus F1n. And similarly, we have some limitations of Coulomb's law. It is valid only for the point charges. It is not valid for the continuous charges. And similarly, it is valid only when 2 point charges are stationary. It is not valid for the moving charges. Thank you very much for watching my video. And if you will have any question, you can ask in the comments.